Imagine knowing about a tornado days before it forms. Imagine receiving a warning about a flood before the first raindrop falls. Imagine being told that a hurricane is going to strike your city not hours in advance, but a full week in advance with enough time to evacuate, secure your home, and protect your family. For the entirety of human history, natural disasters have struck with terrifying suddenness. They have wiped out cities, ended lives, and devastated economies in moments. But something extraordinary is happening right now that could change that reality forever. Artificial intelligence has reached a point where it can predict natural disasters days before they strike, with a level of accuracy and speed that traditional weather science could not have imagined just a few years ago. Welcome to AI Got This, the channel that shows you how artificial intelligence is solving some of the biggest challenges humanity has ever faced. Today, we are exploring one of the most important and underreported AI breakthroughs of our time: how artificial intelligence is revolutionizing disaster prediction and could save millions of human lives in the years to come. Hit that like button, subscribe to AI Got This, and stay with this video until the end, because what you are about to hear could literally save your life one day. Let me start with the scale of the problem this technology is trying to solve. According to the United Nations Office for Disaster Risk Reduction, the world suffered over 7,300 major natural disasters between 2000 and 2019. Those events killed more than 1.2 million people and caused over $3 trillion in economic losses. And the trend is accelerating. Climate change is producing larger storms, more intense floods, longer droughts, and more frequent wildfires. The frequency and severity of natural disasters is rising faster than at any time in modern history. And the traditional methods of predicting these events, the weather models humanity has relied on for decades, have fundamental limitations that artificial intelligence is now able to overcome. The first major breakthrough is a system called Aurora. Aurora is a new AI model trained on over 1 million hours of weather data, an unprecedented quantity of information about how atmospheric systems behave. Unlike traditional weather forecasting models, which require massive supercomputers and enormous teams of human experts to operate, Aurora delivers faster, more accurate, and dramatically more affordable forecasts for a wide range of dangerous events, including extreme weather, air quality crises, and ocean wave conditions. According to the researchers who built it, Aurora could revolutionize how the world prepares for natural disasters and how it responds to climate change. This is not just an incremental improvement on existing forecasting methods. This is a fundamentally new approach to understanding and predicting the behavior of our planet's most dangerous natural systems. The implications are staggering. Imagine a hurricane forming in the Atlantic Ocean. Traditional forecasting can identify it once it has developed, track its movement with reasonable accuracy for a few days, and provide warnings to areas in its path. But the projections become increasingly uncertain the further out you try to predict. 5 days out, the cone of uncertainty for a hurricane's path can be hundreds of miles wide. Aurora and similar AI systems can now significantly extend the time horizon over which accurate predictions are possible. Communities that previously had 2 or 3 days to prepare for a major storm may soon have a full week. 2 extra days of warning time means more evacuations completed safely, more homes secured, more medical preparations made, more businesses protected, more lives saved. In Hong Kong, researchers have built an AI system specifically designed to predict severe thunderstorms, including the catastrophic black rainstorms that have devastated parts of Asia in recent years. This AI model can predict dangerous convective storms up to 4 hours before they strike. It improves forecast accuracy by over 15% at the 48-kilometer scale compared to existing systems. Now, 4 hours might not sound like a long lead time compared to a week, but for sudden convective storms, events that traditional forecasting often cannot detect until they are already forming or arriving, 4 hours is the difference between disaster and preparation. 4 hours is enough time to move children to safety. 4 hours is enough time to relocate vehicles. 4 hours is enough time to alert vulnerable populations and activate emergency services. The Hong Kong system is being integrated into the national weather forecasting infrastructure across China, a country with hundreds of millions of people living in regions vulnerable to exactly the kinds of storms this technology now predicts. In the United States, the National Science Foundation's National Center for Atmospheric Research has deployed an AI weather model called the Medium Range Real-Time Convective Hazard Forecasting System. This system can predict severe weather hazards, including tornadoes, large hail, and damaging winds a full week in advance. Let me say that again clearly. AI is now predicting tornadoes a full week before they happen. And the predictions are not just rough estimates. They identify specific regions where the risk is elevated, allowing emergency managers, local officials, and individual citizens to prepare days in advance. The forecasts are run daily and made available online. They are being evaluated at the National Oceanic and Atmospheric Administration's Hazardous Weather Testbed as part of an effort to integrate AI forecasting into the official warning systems that millions of Americans depend on. The technology is no longer experimental in the way it was a year ago. It is becoming operational. What makes these AI systems so much more capable than traditional weather models is fundamental to how they work. Traditional weather forecasting relies on mathematical equations that describe the physics of the atmosphere, temperature, pressure, humidity, wind, and the relationships between them. These equations are powerful but computationally expensive. Running a high-resolution weather forecast can take hours of supercomputer time. AI weather models work differently. Instead of solving physics equations from scratch, they learn patterns from massive amounts of historical weather data. They identify what storms look like as they form, how atmospheric conditions evolve, and what subtle signals precede major weather events. Once trained, these AI systems can produce forecasts in minutes that would take traditional methods hours to generate. They use a tiny fraction of the energy. And in many cases, they produce more accurate predictions than the physics-based models that previously represented the cutting edge of weather science. The implications extend far beyond weather forecasting. AI is being used to predict floods with unprecedented accuracy, to identify wildfire risks days before fires ignite, to anticipate droughts months in advance, to detect early warning signs of earthquakes and tsunamis, to model how disease outbreaks will spread through populations. Every major category of natural disaster is being transformed by AI prediction capabilities. And these capabilities are not just being developed in research labs. They are being deployed by government agencies, emergency response organizations, insurance companies, and humanitarian groups around the world. The result is a fundamental shift in humanity's relationship with natural disasters. For the first time in human history, we are beginning to see the major events of nature coming before they arrive. And that capacity for advance warning is going to save lives at a scale that previous generations could not have imagined. There is also a deeply important aspect to this transformation that does not always get attention. AI weather forecasting is making this technology accessible to countries and communities that previously could not afford advanced disaster prediction. Traditional weather supercomputers cost hundreds of millions of dollars. Operating them requires teams of specialized experts. The result has been a global inequality in weather forecasting capability. Wealthy countries with sophisticated systems, developing countries with much more limited tools. AI weather models can run on dramatically less computing infrastructure. The cost barriers are falling. Smaller countries, smaller cities, and even individual communities can now access forecasting capabilities that were once available only to major scientific institutions. The democratization of disaster prediction is one of the most underreported benefits of the AI revolution. And it is happening right now. The implementation challenges are significant. AI weather models are powerful, but they are not magic. They require enormous amounts of clean, accurate training data. They sometimes make mistakes that traditional models would not make. They can be overconfident in conditions where they have limited training data. Researchers around the world are working to ensure that AI weather systems are reliable, transparent, and integrated with traditional methods rather than replacing them entirely. The most effective approaches combine AI capabilities with the rigorous physics-based models that meteorology has built over decades. The future of disaster prediction is not AI alone. It is AI working alongside human experts and traditional science to produce predictions that are better than either could achieve independently. Here is the question that matters most for every person watching this video. What does this mean for you personally and for the people you love? It means that in the years immediately ahead of us, you are going to see weather warnings becoming more accurate. You are going to see longer lead times before storms. You are going to see evacuation orders becoming more precise. You are going to see emergency management improving dramatically. The systems being deployed right now are already saving lives. The systems being developed for deployment over the next 5 to 10 years could save millions more. This is one of the genuinely good news stories about artificial intelligence, a story where the technology is being directed at the most fundamental human challenge of survival in a dangerous natural world. And it is a story that everyone has a stake in, regardless of where you live or what your background is. If this video gave you a new perspective on what artificial intelligence is making possible, share it right now. Send it to anyone living in regions prone to natural disasters. Send it to anyone who has ever lost something to a storm, a flood, or a wildfire. Send it to anyone who needs to hear good news about technology. Hit the like button because it helps AI Got This reach more people who deserve to know what is being built. Subscribe and turn on notifications. Every week we explore how artificial intelligence is solving real human problems and creating a better future. This is AI Got This. The disasters are predictable. The lives are savable. Stay curious. Stay informed. And whatever you do, never stop believing in what humanity can build when we use technology for the right reasons.